So let's say you're given that the following. So the main thing that you need to recall it is, in fact, before maybe I start with this problem, because maybe you're stuck, you don't know what is, let's say, ln, or ln, it's ln, or natural logarithms. So please always know that, let me write here, recall that log to the base is the same as when you see ln, isn't it? I hope you still recall that. So if, for an example, now I put x here, log of x to the base is the same as natural logarithm of x, ln x. That's the very important that you need to know. And again, something that you need to recall is changing from exponential form to logarithmic form, from exp to log form, to logarithmic form. So it's just that when you do other problems in mathematics, you have to recall all the basics that you know when it comes to solving problems. You can meet factorization while now we're solving determinants. You can meet a word mass. So let's say, for an example, when you change from logarithmic to exponential form. So we know that if, let's say, you have, let's say, log, let me use base in the log of x to the base. Let's say it's equals to 1, for an example. So if you have to change from logarithmic to exponential form, so always, whatever that is a base in logarithmic, it will be a base in exponential. And always note that logarithm, it's always equals to the exponential, exponent to say. So this is our exponent, this is the base. That is the key part. So when you change from logarithmic, so I know that, right, when I change, I'll have e to the power of x, with y to say, equals to x. In fact, there's not that clear. Let me write it down here. So I'll know base is e, therefore exponent is y. Then whatever is remaining the variable that was in the, whatever is in the log, it is equals to the exponent. So that was the change. So always, whatever is based on the logarithmic, it will be the base in the exponential. So we have a base here, we have an exponent. When you interchange, you're going to say, excuse, log of x to the base e. Let's say, for an example, I introduce the log again here. So some of you are used to introducing log. So if I introduce log, um, I said that is a base, but it's fine. Let me introduce log or natural logarithmic. Let me introduce a log to the base e, or let me just leave it as log of e. So if I introduce log, I drop down the exponent. Therefore, even on the other side, I introduce a log. So I'll have y log e equals to log x. When you solve for y, making y subject of the formula, I hope you see you'll have log of x divided by log e. The rule states that if, let's say, you have log which is the similar base, I hope you remember that there's an invisible base 10 in both logs. So you're allowed to compress it if they have the same base. The one which is dividing, it will be, put it here. The one that is dividing, you'll have y equals to the one which is dividing, it will be your base. So you'll have log of e, log of x to the base e. So still goes back. So yeah, but not to waste time to introduce log, just know that, oh, I have base there. Always a log is equals to the exponent. So I'll say log of x to the base e equals to 1. So that is the knowledge that you were supposed to recall when you're supposed to solve this problem. So but let's get into solving for x there, this one. So let's take it to that side. So we will apply our evaluation of the second order determinant, where we're going to say half times 6, which is 3, right? Therefore, minus 10 by 2 over 5, which is 4, right? Which is 4, equals to ln x, and therefore ln x. So here we have negative 1 is it? Therefore is equals to ln x. So now we need to solve for x. We know that this is a log of x to the base e. So we know that log is always equal to the exponent. So this is our exponent. So I'll say that e to the power of negative 1. E to the power of negative 1 equals to x. Therefore, you have your answer. You can leave it as it is or in decimals. But x is equals to 1 over e to the power of 1, making the exponent positive. Drop down the base. The exponent changes to become positive e. I hope it's clear.